Hi, Achla here. So today I want to talk a little bit about server components, React server components namely, and of course then dig in a little bit on a Next.js app that's using them, how the mental model has changed from regular client components to server components, how I implemented that app on the first Next.js 13 release when they introduced the experimental support. And then we're going to have a look on what has changed because I haven't touched the app much since then, and we're now a few minor versions ahead. The app itself is an IMDB's poor man clone, which of course I'm using Xata as the database, and I'm implementing with a little bit of search and aggregation to it. So let's jump into Let's talk a little bit about Xata. So Xata puts a few different data-related solutions together behind the same API. That's why sometimes I consider calling it like a database a bit of an understatement. It has search and a relational database on the same layer. The plan is to be a serverless solution for all your data needs, from schema branching to performance delivery. And now that we have that information, we're ready to dig into React. So server components are the culmination of a lot of work that has gone through building what's concurrent React. It is the door to use server-side streaming and partial hydration in your app. In other words, it represents a huge performance boost to any app that successfully uses them. This is because it reduces your page's JavaScript footprint dramatically by having the bulk of processing and logic on the server side. What ends up down the wire is mostly static. So less code, less hydration means less work to be redone when your app reaches the user's browser. That's the gist of the benefits around using server components. The catch, though, is that this forces a paradigm shift on how we're building our components to this day. Our apps are engineered to route-based data fetching. Every route has its own root component, and that root component is responsible for managing data and cascading down this data as props to the other components, their children components. Basically like a mama bird feeding the little ones. So looking at how we start our next apps, what we have is essentially the first route, which I'm calling it /home. And then we start building components for them. And then we have the navigation component, we have the footer component, we have probably a gallery component, we have a header component. And the way we have built apps with the page directory so far and with essentially any kind of meta framework that uses React is the route is responsible for fetching the data and then cascades this data down as props using probably a context API or like whatever logic you want to do for each component. So we're feeding those components with data. Suddenly we start like scaling up, and then we have a new route. And this new route uses the same components and maybe not exactly the same, probably a different one, which is now the about routes using this company information that we're also fetching from a CMS. And it's a little bit different. But what we have in the end, these two routes working independently, and they're all fetching more or less the same data, and they need to provide our components with the data that they need to render. So that's been the current mental model that we have dealing with client components. So now with server components, each bird is now responsible for fetching their own data. So data fetching starts happening on a per component basis. So naturally, you're already thinking, oh my God, I'm going to make the same request over and over again. And yes, that's why React has some intelligent fetch deduplication happening under the hood. And yes, it does tweak around the fetch implementation, but controversies aside, it's working. The crux to server components is collocating the data fetching layer with your rendering logic. This means moving the serialization boundary to the component level, which essentially makes our components static by default. This means that now we need to be explicit when we want to add interactivity and when we want to add client-side logic to our components using the use client directive. So when we start dealing with server components, the idea of handling the data breaks out of the route. So it doesn't really matter which route is rendering the components, because the components are responsible for their own data, which means that in this case, my navigation component is going to fetch the page map. And then if I have another component that needs that page map as well, this page map is also going to be fetched by that component. So we're going to have like the same endpoint reaching twice. And then the company component is going to be responsible for fetching that information from the CMS about what they need to show on the company component level, and same for the gallery, which means that as we're adding components to our routes, the components are bringing also their data. So they are encapsulated. They are single units, which also means that my header component that doesn't really care about any kind of data can be fully static. So minimal JavaScript footprint for that one. And before you get worried about it, if multiple server components are reaching the same endpoint, that request is going to be deduplicated. So this means the nav and the footer component, because they're on the same render, it's only going to happen once. So now we have actually 3 requests if we're using the same 3 components on the same rendering. So it's performance optimized for the server as well. So that's the gist of the mental model we need for the server components right now. And with that, we're ready to jump into the code. So this is the Xata movie database. It is already working. It has all my server components. It has some streaming to it. Each result has their own page, and we can also search through it. And it's gonna fetch the records with some nice streaming to it. And then we get the proper response. So search is working. It is though using some older features. So let's dig into the components and to everything that's making it work. This is the app we're gonna be working on. It has a few components here that I still like to put them separated if they're not like specific to a route. And we do have inside our apps, we have the routes that we're building, and we have the root component. So as you can see, we're still using a head component, which was from the first releases. We need to update that. We have our layout component, that's the root layout, and it has some basic markup. We have a loader, that's the one we're going to be using in our suspense boundaries. And talking about suspense boundaries, on the page we're setting up the suspense boundary. There's a TypeScript error here because we cannot have asynchronous components according to TypeScript, but it still works. And we're doing one request here that is for the aggregation. So that's basically when we're showing the number of titles we have for the header navigation. So that one, we wait for the render to happen. And then the other one, which is the search result. So that response is the one that's getting streamed on. And then we have a route for every movie. Whenever we get a movie, we have the ID as a param. So each movie has their own route. And then we fetch the information from that movie. If we don't have the information, we're going to return a 404. And then as we destruct that and we create our basic React component, which is the same as any React component you've worked on. For the search, we also create a separate page for each search result. And we receive the term that has been searched as a parameter. We fetch the number of total titles that we have used to search on again. And then we put the search result, which is the same one as inside the suspense boundary, with the difference that now we're passing down what is our actual search going to be. So we're passing to the search result the responsibility to actually do the search. So we're passing some decode URI here for the search term, and then the search result is responsible for its own data. What's going to happen is that we have this get movies, which is going to just basically pass the search result. And then this one we can await because remember that it's inside a suspense boundary. So we wait for this one to render. In case we don't have an actual result, we just reply with a silly message. Otherwise, we're just going to have a regular movie list. So that's basically it. That's an overview of each component and how they work. For some of our components, for example, the search one, this one is actually a client component. So this one, we're actually using the router, and that's how we're gonna be pushing the search. So what we do here is essentially like I have a form component, and this form component I'm preventing the first navigation on prevent default. But actually in the end, what I do is I get the form data from the event that I'm sending to the form submit, and I'm gonna push that into the router. So this means that the search is gonna happen on my backend, so I don't need to do any kind of data fetching from the client side. So I leave my server component to actually connect to my database. That's basically it. We don't need to do any kind of fancy use effect. We don't need to handle any kind of other stuff, because what's gonna happen here is that this is gonna trigger a navigation. And then we have our database library, which is essentially getting a Xata client here. And I'm using the types that are coming from our SDK, because Xata has a code gen. We can get like a few facts from it. So we're using aggregations now to sum all our votes, some nice stuff about the ratings and so on. And finally, our search has like some boosters to make sure we are getting the relevant titles. So yeah, that's how we implemented the search. And now let's jump in. So let's get started by refactoring the head to use the new object. That's the meta object. And with this, we're good to go. We hoisted now, properties we repeat. We have now the icons, we have an open graph, and we have Twitter. So now let's actually move all of this to our layout component. And so it's gonna get inherited by our other routes. So this is now essentially already working as a fallback. And now we can go to the other route that we have, which is the movie route. And we're gonna start working on generating the metadata for this one. So in this one, we're gonna use the generate metadata, because we actually need to use the search params, and then we're gonna return the actual meta object that we need. So we don't need to do favicon anymore, but we do need this logic over here. So let's just simply copy paste the logic, and we just fix the types, and now we have all the logic we need. We typed the metadata, and now we're going to return the open graph with title, description, and finally Twitter with the same title, description, and images being our image. So with this, we're done. And bring up my favorite browser, CZ, to check how our tags are being generated. We have all of them over here. And if I click inside this one, I can reload the page, and it doesn't work. So checking out here, I get all my default values. The problem is actually right here. There's a typo. So now by changing this, we go back and refresh, all our metadata is there. Everything works. Perfect. So now we already refactor our metadata. We can go back and we can see if we can actually stop using the page directory completely by adding a route handler. So the way that the route handler is going to work is that we're going to add a new API/OG/routeTS, and we're going to export an asynchronous function that we're going to name get, and this is gonna receive a request. And so we can now copy paste this logic over here, because it's already on the edge runtime, and the route actually needs to be TSX, TypeScript to be okay with it. And we also need, instead of response, we need an image response that's coming from Vercel OG. So, okay, no more TS errors. What we need to do now is we have conflicting routes in this. So this is going to be a problem. Let's straight up delete it. Our server is still running. And with that, on refreshing, we need to be able to see still the same one. And here we go. Refactor. Now we're using the route handler as well. So yeah, we just played around with server components, and I hope this helped you get your feet wet with them, and leave me any feedback on the comments below. Otherwise, I'll catch you on the next one. Bye.